Okay, so f of x is x squared plus 4, g of x is square root of x minus 3. Then f plus g of x means what? It means f of x plus g of x. It means we add the f of x function, which is x squared plus 4, to the g of x function, which is x minus 3. It doesn't hurt to put this in parentheses just to get in the habit, because this stands for one function, this stands for another, and you can clearly see how these expressions connect back here. And you see it a little more clearly if you put the parentheses around it, but it wouldn't be required in this case. Okay? And then, of course, we can rearrange the order of these things in decreasing powers. This is the second power, this is the 1/2 power. That's 4 times the 0 power of x. X to the 0, of course, anything to 0 is 1. Okay? Then, there's always a temptation to write that as the square root of x minus the square root of 3 because you're used to the distributive law. It doesn't apply to powers. The square root of x minus 3 means x minus 3 to the 1/2, right? Okay, there's no distributive law in a case like this. Nothing at all that justifies it. It's distributive law of multiplication over addition. Or subtraction, but subtraction is just like an addition. Okay? Make sense? Okay. Now, fg of x means f of x times g of x, just exactly what you'd think it means. And that's x squared plus 4 multiplied by the square root of x minus 3, but there's something wrong with what I just wrote down, which is,
parentheses.
before I put the parentheses there, only the 4 was multiplied by the order of operations. You do multiplications before you do additions. There's nothing you can do with that. Okay? F over g of x, well, that's f of x divided by g of x, and that equals x squared plus 4 over the square root of x minus 3. Now there's a little something I want to add here. Probably, well, you haven't maybe encountered this yet, although you were talking about domains before. The domain now is restricted. Okay? X has to be greater than or equal to 3, otherwise you have a square root of a negative, right? And of course we talked about domains and ranges previously. Okay? Okay, then g over f, that would be, I was careless. I said greater than or equal to 3 because of the square root, but it can't be equal to 3. Why not?
It has to be 0. It can't
Yeah,
be.
you can't have 0 in the denominator, so get rid of that equal. Okay? And down here you have the square root of x minus 3 over x squared plus 4. And now x can be equal to 3 because there's nothing wrong with having a 0 in the numerator.
Right.
If x happens to be 3, the whole thing is 0. And the other thing is the denominator can't equal 0 because x squared can't be negative, and you're adding 4 to it. You're never going to get a 0 in the denominator. You're always going to get you're never going to get a number less than 4.
Right.
Because x squared can't be less than 0. Okay?
Okay.
And of course, even if it was x plus 4, you wouldn't want x to be negative 3 or negative 4, but it's going to have to be greater than or equal to 3 because of this anyway. So you want to think these things through. So, yeah, that's how you do these.